In this video, we are starting a chapter about design of epidemiological studies. There are many different types of studies. Some produce evidence which is very weak. On the contrary, some produce findings which are highly reliable. Here you can see a so-called hierarchy of evidence. At the bottom, there are case reports and case series that produce the weakest evidence. A little bit better than them are so-called ecological studies. One step better are cross-sectional studies. Already quite good are case control studies. Above them are cohort studies. Even better than cohort studies are randomized controlled trials. And the best possible evidence is produced by systematic reviews and meta-analysis. These many different types of studies can be actually divided only into two groups: studies observational and experimental. Observational studies can be descriptive and analytic. Descriptive studies are fast, cheap, easy to understand. They provide quick knowledge and can generate hypotheses. Hypotheses are tested in analytic studies that go much deeper. Experimental studies, also called interventional, are the best possible studies, especially when they are designed as randomized controlled trials. The biggest difference between observational and experimental studies is that in observational studies, the researcher is somehow a bystander. The researcher just observes the study participants. It does not interfere with anything in their lives. The researcher just collects data about them and analyzes them. However, in an experimental study, the researcher causes an intervention and changes reality of the study participants. On the bottom of the hierarchy of evidence are observational studies that can be called descriptive. Descriptive observational studies are cross-sectional studies, ecological studies, and case reports or case series. A little bit better than descriptive studies are observational analytic studies. These are cohort studies and case control studies. And the only experimental study we will talk about is a randomized controlled trial, which is by many people, many researchers considered as gold standard in research. In this part of the video, we will talk about descriptive studies. The lowest possible evidence is created by case reports or case series. Case reports and case series generate hypotheses, stimulate further research, give fast information, are immediately understood by experts as well as the general public. Case reports inform about unusual diseases of an individual. Case series inform about such unusual disease occurrence of several people. Even though they are at the bottom of the hierarchy of evidence and cannot prove an association between exposure and outcome, some case reports and case series have been very useful. For example, it was case reports that informed about thalidomide, a drug prescribed to pregnant women, causing malformed limbs of their babies. Among more recent examples, case series highlighted a possible connection between microcephaly and Zika virus. We will now move up the ladder of the hierarchy of evidence and talk about so-called ecological studies. Here is a great example of an ecological study. Researchers posed a question whether the Nobel Prizes are caused by chocolate consumption. They collected data on the level of countries about how much chocolate is consumed in each country and how many Nobel Prizes were awarded to these countries. The relationship between these two variables in an ecological study is expressed with a Pearson's correlation coefficient R. Therefore, ecological studies are also called correlation studies. In this case, the R is very high. It reaches 0.8, which indicates a strong correlation because the maximum is 1. However, The authors, of course, did not take into account other reasons for the correlation between chocolate consumption and Nobel Prizes, such as GDP or research funding in each country. This is a case of a so-called ecological fallacy. Moreover, this correlation was studied on the level of countries using aggregated data from national statistics. There was no individual data used. So this correlation says nothing about who actually eats the chocolate in those countries, whether it is the Nobel Prize laureates themselves or not. This is called aggregation bias. Another absurd example of an ecological study is a correlation between wearing hats and having lung cancer. Here we compare three groups, A, B, C. Each group has 5 members. In group A, one person wears a hat and one person has lung cancer. So 20% of the population wear hats and 20% have lung cancer. In the group B, 2 people wear hats and 2 people have lung cancer. So again, 40% of the population have hats and 40% of the population have lung cancer. In group C, 3 people wear hats and 3 people have lung cancer. That means 60% of the population wears hats and 60% of the population have lung cancer. The correlation again is very strong. There is a significantly strong relationship between having a lung cancer and wearing hats. But of course, hats don't cause lung cancer. Group comparisons do not necessarily apply to individuals. But if we study this with an ecological study, we can sometimes find these very improbable results. But not all ecological studies are so absurd. They can be very useful. They are hypothesis generating. They are fast, inexpensive, because they use available secondary data from population statistics that already exist, which saves a lot of time. There is not a need to collect new data. We need to have, however, an appropriate question which can be answered with such ecological studies. A great question would be, for example, will tax increase lead to decrease in cigarette consumption? Now let's discuss the best descriptive studies we have, and that is cross-sectional studies. Imagine that you are at home and somebody rings the bell and asks you whether you have time to answer some questions. They are probably conducting a cross-sectional study. Cross-sectional studies give a snapshot of the reality. They are used to assess, for example, the prevalence of diseases. The assessment is happening just once. There is no follow-up. These are prevalence studies, so assessment of incidence is not possible. We need to take into account that we can measure prevalence of a disease at the certain time point. However, those who were cured of the disease before or died of the disease before will not be captured in the study. So this all needs to be taken into account when we try to estimate the prevalence of diseases. A cross-sectional study was conducted to estimate the prevalence of mental disorders in the Czech Republic. This study found that the highest prevalence exists for alcohol use disorders, followed by anxiety disorders, then mood disorders, then drug disorders, and the rarest disorders in the population were psychotic disorders. The design of a cross-sectional study is more appropriate to capture chronic diseases that have a long duration. Acute panic attacks that start abruptly and disappear quickly are unlikely to be captured in a cross-sectional study. Also, severe mental disorders that led to suicides could not be taken into estimations either. Even though cross-sectional studies are best to study the prevalence and are not the most appropriate design to assess an association between exposure and outcome, they already can suggest a relationship between two variables. Here we can see the prevalence of alcohol use disorders stratified according to educational attainment. There is a clear association between lower education and higher prevalence of alcohol use disorders. However, because all measurements were taken at the same time and only once, we cannot know what was first, whether low education led to alcohol use disorders, or whether alcohol use disorders are barriers to educational attainment. To summarize, descriptive studies can be case report or case series, ecological, in other words, correlation studies, or cross-sectional studies. In case report, we have one individual. In case series, we have several individuals. In an ecological study, we study groups. We have only aggregated data. We don't work with individual data. In a cross-sectional study, we are working with a population of individuals.